Question about electricity. We've got a halogen lamp with a power of 50 watts when operating at its normal voltage. Calculate the amount of electrical energy transferred in 40 hours. So you've been given a power and a time, and you want an energy. So the equation you want to use is energy equals power times time. Again, write that out in words just in case. But that's worth 3 marks, so you need to obviously do something extra, and your time is in hours, so you're going to need to convert that. Watts is fine, so 50 watts, but then your time, it needs to be 40 hours times 60 to turn it into minutes, times 60 to turn it into seconds. So then you should end up with a big answer, which is 7,200,000 joules. So a student notices that in addition to producing light, the lamp also gets hot. She concludes that it can't be 100% efficient. Explain whether that's correct. So it is you knowing the meaning of the word efficient. So something that is 100% efficient, it means that all of the energy input is turning into a useful energy output. Now for a lamp, the useful energy, the energy that you want, is light. But obviously if the lamp is also getting hot, that means that some heat or some thermal energy is also being produced. So yes, the student is correct, and your explanation is because energy is obviously being wasted as heat, which means that not all of the energy is going into producing light, which is the useful form of energy that you want. Okay. The lamp must not be connected directly to mains voltage. And if you remember, that's 220 volts. A step-down transformer must be used. To describe the structure of a step-down transformer, you may draw a diagram. Okay, so they're giving you a little space. So definitely always helpful to draw the diagram. You have your iron core. On one side you have your primary coil. Going in here, your primary coil. And on the other side you've got your secondary coil with your output voltage. And if you remember, the the number of coils is what decides whether it's going to be a step up or a step down. Now this is a step down transformer, which means there will be less turns on the secondary coil and more turns on the primary coil. That's what makes it a step down transformer. And that's basically it. So you can draw that, which will help you get most of the marks. You are looking for these main points, that you've got 2 coils of wire, which we've drawn, one of them quite badly. You've got an iron core. Label that up, that it's got to be iron because it needs to be a soft magnetic material. It needs to be something where the magnetism is easily changed. And your 3rd mark is that you need to have more turns on the primary coil and less turns on the secondary coil. So we've got a step-down transformer reduces voltage from 230 to 12 volts. So let's call the 230 V1 and the 12 volts V2. The secondary current is 4.2 amps. So we can call that I2, or you can call it V primary, V secondary, I secondary, don't really mind. So state the equation linking input power and output power for a transformer, assuming it's 100% efficient. So that equation, and you've got a clue here because we're talking about voltage and we're talking about current, is that your first current, your primary current, times your primary voltage is equal to your secondary current times by your secondary voltage. Now I'm using 1 and 2 basically because it's easier for me to write with my finger, but you can call that P, that's not too bad, and you could call that S as well, so primary and secondary. And then once you've got that equation, you can calculate the primary current. Now just to note, this version has come from PIV, P equals IV, and we're just letting the power to begin with be equal to the power at the end. That's what the 100% efficient bit of information is telling you. So now we've just put in the numbers in, just make sure you get them in the right place. So we're calculating IP, don't know that yet. VP is 230, and then your secondary current is 4.2, and your secondary voltage is 12. So rearranging all of that, you should end up with a primary current of 0.22 amps.